Welcome to this video series that describes making a steam test plant. I had wanted to put together a steam test plant so that I can run my collection of model steam engines on steam. This video describes initial disassembly, hydro testing and cleaning the boiler. The boiler came from a steam plant that I won at auction a couple of months ago. I decided I would use the boiler for a steam test plant. This photo shows the general arrangement of the original steam plant. The engine is from a Oct''25 popcorn machine. I'll be restoring this in a later video series. Here's a couple of close-up shots of the boiler. Overall, the boiler looked to be in good shape. I decided to fully overhaul the boiler as I build the test plant. I'll rebuild it with new fittings, valves, and other components. Here's a close-up photo of some of the boiler components. They were old and probably brittle from heat. Brass has a tendency to go brittle after being subjected to heat for long periods of time. Changing out the components was probably a good idea. Here's a photo of the burner assembly for the boiler. The assembly had been made from cast aluminum, and this had warped due to heat. The burner would need replacing as I rebuild the boiler. The components removed from the boiler were placed in a storage tote. Most of the parts will be discarded once the boiler rebuild is complete. Next, the boiler was prepared for hydro testing. I put plugs in all the boiler bushings and connected my hydro testing pump to the drain port on the boiler. I slackened the superheater coupling nut so that air could be displaced by water as I filled the boiler. I filled the boiler with water until it flowed from the superheater coupling, indicating all air had been displaced. With the boiler filled, it was time to pressurize it to twice working pressure, which was 200 psi. At 200 psi, I closed the water valve to lock the pressure into the boiler. Here's a close-up shot of the pressure gauge on the hydro testing rig. The dial is at 200 psi. I left the boiler at this pressure for around 30 minutes. After 30 minutes, there had been no reduction in pressure. This indicates that the boiler has no leaks and can be used to generate steam safely. After depressurizing the boiler and disconnecting the hydro testing rig, I began the descaling process. This will remove any scale from inside the boiler and ensure the boiler tubes are clean. Any scale buildup impacts the efficiency of the boiler. This clip shows the boiler being filled with descaler. I topped the boiler off with water and then left it for 2 hours per the instructions for the descaler. This will give the descaler time to loosen any scale on the inside of the boiler. The loose scale will be flushed out with water later. After 2 hours, I drained the boiler into the kitchen sink. The liquid that ran out of the boiler had black particulate matter in it, indicating that the descaler had done its job. Next, I flushed the boiler with tap water. I filled the boiler with water, shook the boiler to remove any debris from the tubes and shell, and then let it drain. I repeated this process a few times until the water ran clear. This indicated that any scale had been flushed from the boiler. After completing the flushing process, I left the boiler to air dry for a couple of days before starting the next step. So, that's part 1 of building a steam test plant. There's quite a lot of work ahead to get the plant built. I'm looking forward to any challenges this presents. Thank you for watching this video. Please like and subscribe to support my channel. Thank you.